All right, so I think this is page 12 in your packet. Is that right? And you had done 1 through 11 yesterday, but let's talk about 12 through 18, and then I'll come around and stamp you guys while you're working on it. Okay, so let's look at number 12. So this first one says, find the proportion of observations between 176 and 186, or 85. So we know we've got an area, and we're going to have to find an area between two amounts. Okay, so that's what we've got to locate. What seems to be strange about numbers such as 176 and 185? What's weird about those? Can you go search for those on your Z chart? Okay, why? Those are just X values. Those are just the data values. Those aren't Z values. Those aren't Z scores. Ta-da, that is the big deal. These are X scores, not Z scores. So, what should we do? If I know the mean and I know the standard deviation, I can do what with each one of those? Find their Z score. So that's what we want to do. So I'm going to take the first one and I'm going to go Z equals X minus the mean over the standard deviation. X minus the mean over the standard deviation. Okay, so I get that one. And then I'm going to do the same thing for the 185 X value. So there's my X minus the mean over the standard deviation. X minus the mean over the standard deviation. So I find each one of those Z scores, and once I find those Z scores, then I can go look at my chart and locate that area in that section. Okay, this was number 12. Let me put this on here. Those end up being really, really close together. I think one of them's 0.093, one Z score, and then the other Z score is 0.5116 or something like that, 0.511. Okay. So, looking at our chart, what am I going to do to find that area in between? Find the area for which one? Oh, people were getting these confused. They wanted to just now go, oh, 0.5116 minus 0.093. That's not it. These are not the areas. Those are the Z scores. So you have to go look up these numbers on the chart. So we're going to go to our Z chart and find 0.09 right here. There's that lower area. Then the other one was 0.511 something. So here's the other area. And then you subtract those. Okay, so be mindful of that. Those are the Z scores. They look like decimals, so you get them mixed up and think they're areas. All right, so let's look at number 17. Okay, so actually number 15. We'll look at 15. So for number 15 through 18, you don't draw the pictures on these. You will be given 3 out of 4 items, and you'll find the fourth. Okay, so let's do number 15. Okay, number 15 says, find the mean. It says, what is the mean? And it says, the number 75. So where does 75 go? What variable is? Good. The number 75 means that 75 is the X value. Good. Is 1.6 standard deviations above the mean? What does that mean? 1.6 standard deviations above the mean is what value? What tells you how many standard deviations above the mean? Z-score, so 1.6 standard deviations above the mean. And then it tells you the size of those standard deviations is 12. So now that I have 3 out of the 4 items, I can put it into the Z-score formula and solve. Okay? So you do your algebra stuff from there and you solve. Okay? That's what 15 and 16 are like. 17 and 18 are similar, except for the missing value is the standard deviation. All right, so I'm going to let you guys work on numbers 12 through 18 while I come around and stamp you for last night's homework. I'm going to do that on your pink sheet as well, okay? So have that ready for me and work on these numbers 12 through 18. Go to page 6. I'm going to go ahead and go over this homework. Okay, so this was that first homework assignment we did after the first day. So I'm going to quickly go through those, and then you guys can just ask me questions. So this one, it was skewed right because the mean is larger than the median. B went between 350 and 950. On C, it gives each employee a $50 raise. So that's a shift of $50. So all the data goes up 50, so everything changed except for spread. So the IQR, standard deviation, and range did not change. Now on part D, or C, or whatever that part is, it was a 10% raise. That's a multiplication factor. You're basically multiplying by 1.1, and that changes everything. So everything increased by a 10% raise. All right. This next one, you wanted to see which is more unusual, 55 degrees in January or 55 degrees in July. So you got the Z-score for both, and you wanted to see which one was farther away from the mean. And even though this July was negative, it didn't really matter if they were negative or positive. You were just seeing how far these Z-scores were away from the mean, and the one farther away was more unusual. So the July is more unusual. Number 3, about the cattle, there was your Z-score for part A. For part B, you were wondering which was more unusual, so once again you found the 2 Z-scores and you compared them. And the 1,000-pound steer was more unusual because it was 1.8 standard deviations below. This other one was 1.16 repeating. Okay? All right, next. Up here we've got a subtraction of 1,000. And so, all right, so again on part A, a shift only changes the center. The spread, the standard deviation stayed the same. But part B, it is multiplication. It's a transformation, changing pounds into money, and that multiplication affects both center and spread. All right, here's how the pictures looked. So for part E, or for part A, you were drawing the pictures and putting in the percentages, and it asked you for the context information. So that was the miles per gallon. Make sure that you are labeling. And then it had asked for your Z-score. So that was just your 0, 1, 2, 3, negative 1, negative 2, negative 3. Those were the Z-scores. All right, so once you did that and you got those percentages, B is 18.6 and 31. C is 16%. D is 13.5%. And E is 12.4 miles per gallon or less. All right, moving on to the next. Up here, same kind of thing. You filled in the percentages, and then the context were the actual X values. The context are the X values, and the Z-scores are your 0, 1, 2, 3, negative 1, negative 2, negative 3. And so 84%, B is 97.5%, C 2.5%, D 97.5%, E 13.5%, F 47.5%, and G 81.5%. Yes, ma'am. Ooh, maybe I'm wrong. No, I'm not wrong? Okay. Well, if several people did, sometimes I wonder if I'm okay. So from size 10 to 13, so this right here is 34%. This is 13.5. So if you add 34 plus 13.5, you get 47.5. Okay? All right. Moving on to today's. And when I do these, I'm going to teach you a little calculator trick. So be ready. Have your calculators out. Be ready for our new little calculator trick as we do this. So you guys have been using your chart to find these areas, but I want to teach you a way that you could do it in the calculator as well. Sometimes that's faster and such. There are actually notes on this page 11 in your packet. And to find the area below a particular z-score, and that's what we're going to be doing here on this problem. So here we are finding the area below a particular z-score. Then we are going to get the cumulative area on the normal curve. And so the way that's going to look in our calculator is the area below a z-score. We're going to use this function, and I'll show it to you in your calculator in a second. Norm CDF, this C stands for cumulative, so it's getting the cumulative area from the low z-score, your lower bound, up to your higher bound, your upper bound. So if it is below, like in this case here, then we are going, the low bound is basically negative infinity, and you're going up to a z-score of negative 0.66. So the way we would put that into our calculator is we would go norm CDF from negative 99 up to negative 0.66. And let me show you that in your calculator. And some people also have a menu feature, and so I'll address that as well. So where you will find this function is second vars. So go to second vars on your calculator. Number 2 is norm CDF. Number 1 is norm PDF, which we never use. Okay? So number 2, norm CDF. Now, if you have a menu, your menu comes up and it says, what is your lower bound? Well, what did we say our lower bound was? Negative 99 is the lower bound. Okay? If you don't have a menu, you type in the number and you put a comma if you don't have a menu. Then, if you have a menu, it says upper bound. Our upper bound was this value here at negative 0.66. So we type in the upper bound of negative 0.66. If you have a menu and you have the mean and standard deviation, leave them as 0 and 1 as they are automatically that way right now. Leave those this whole year as 0 and 1. Hit enter and voila, you get 0.2546, which is the area that you found whenever you did this on your chart. That way. Nice. Okay, well then let's try this next one. This is a situation where we are going above a particular z-score. See, we're going to go above a particular z-score. So the lower bound that we're going to be putting into the calculator is this z-score of negative 1.3. The upper bound that we're going to be putting into the calculator is what? Negative infinity, or positive infinity. Well, we simulate, I've probably left this off, we are simulating positive infinity by going 99 standard deviations out. Because how many standard deviations are really on a normal curve? You go up how many, and you go down how many on a normal curve? 3, thank you. Up 1, 2, 3, down 1, 2, 3. So imagine 99 standard deviations out. Do you think that's like simulating very, very, very far out there? Yes. So what we will do is go into our calculator and we will do norm CDF from that z-score up to 99 standard deviations, because that is simulating our positive infinity. So here we go into our calculator. Second vars. Number 2 is norm CDF, and the lower bound is, was it negative 1.3? And the upper bound is simulated by the number 99, because that's simulating positive infinity, and that is an area of 0.9031. So see, you didn't have to find the lower area and then subtract it from 1. It gave it to you straight away. Isn't that nice? How about on this? When you are finding the area between 2 points, isn't it a pain? What do you have to do to find that area in between 2 points on your chart? Yeah, you have to find the area below the upper one and subtract off the area below the lower z-score. Well, now you just have to find the area between the z-score by putting the low z-score and the upper z-score, and voila, it'll compute, it'll integrate, is what it's doing, the calculus integrating between those two values. So we're going to go here, we're going to second vars, number 2, I don't remember what those were on here, from 1.2 to 2.5. That's our 1.2 is the lower bound, 2.5 is the upper bound, and there it is, 0.1089. And that's the area you got yesterday with your chart when you subtracted those areas. What do you think about that? You like that process? You are now going to have the choice of doing it in the calculator or using your chart. It's fine. You can use a chart if you like the chart, or you can use the calculator if you like the calculator. Also, I'm not going to make you draw the pictures anymore. So there you go. So that'll be nice. Okay, let's continue on, and I'll show you another calculator function here shortly. Next, on this, the next one, number 4 was 0.1465. Number 5 was 0.0441. Aha, here we go. Number 6. This is a new calculator function I'm about to show you. This one did not ask for an area. What did it ask for on this one? It asked for a what? A z-score. Okay. It asked for the z-score at that spot. So there's a feature in there that in the calculator, it is called inverse norm, because we're going backwards. We are taking the area below this z-score. It always has to be the area below, which in this case is 0.95, and we are putting it in there, and it will give us the z-score at that spot. So in fact, the z-score song is x minus the mean over the standard deviation, x minus the mean over the standard deviation. The next verse is inverse norm of the area below, inverse norm of this area below, inverse norm of the area below is the z at that spot. Okay? So let's find that and do that. So second vars, it's number 3. Number 3, inverse norm of the area below, 0.95, is the z at that spot. Okay? So that gives us 1.645. Voila! And you didn't have to do the backwards thing on your chart. Okay, let's continue and look at the other ones. Number 7 was this lower because of symmetry, negative 1.645. Number 8 actually was just another way of representing number 6 and 7 at the same time. So you had 2 answers on number 8, the negative 1.645 and the positive 1.645. So number 8 you had it was another way of saying the way it said it on number 6 and 7. And I already went over number 9 with you. Number 9 we had talked about doing on this calculator-wise. What would be our way to do this calculator-wise to find the z at this spot? Okay, inverse norm of what percentage? 0.6. So inverse norm of 0.6 would give us this number 0.2533. Okay, next page. Number 10, we could do inverse norm of 0.18 to get a z-score of negative 0.9154, and number 11, 0.6745. Okay, let's go ahead and check the ones that you did today while I was stamping you. So number 12. Number 12, these were your z-scores. These were interesting z-scores. Did I go over that, I think, already? So your area was 0.15 something, 8.5, I think. These are the z-scores. Did I go over that with you? Scores. Okay. All right, good. And then number 13, sorry, number 13, the area was 0.2051. Number 14, 0.0668. Okay. The other ones were algebra involved. They did not have pictures. So number 15. Now I showed different work on mine. So you may or may, don't look at the work I used because I didn't do the work that you would use. But here's another way you can do it. Number 15, the answer was 55.8. Number 16, the answer was 44.25. 43.25. Number 17, it's 6. And number 18, it's positive 19.6. Yes? Okay, good question. Yeah, I had that there. You can see I had a mistake, 9.75, and that's wrong because the z-score is 2.7 or 2.5 standard deviations below. So the z is negative 2.5, not 2.5. Dun, dun, dun. Okay? All right. Does that answer your question then? See if that works when you recompute it with the negative. Okay? All right. Done going over that. Done going over that. Moving on to page 15. Oh, you know, I have on page 15 in your packet, let's practice with the calculator. So here we go. So this first one, you are finding a z-score. So z-score, what do you do to find the z at that spot? Inverse norm of the area below the z-score. So what is the area below on this problem? It says find the z-score of the lowest 10% of data. Okay, so I put it in as a decimal, 0.1. So I'm going to do that, put that in my calculator. Inverse norm of the area below is the z at that spot. And you get negative 1.28. Okay, next. Find the z-score for the highest 5%. Highest 5%. So how do you fix that so it's inverse norm of the area below? 0.95. Good. Is that area below? Is the z at that spot? 1.645. Is that what that is? Okay. Next, find the z-score for the middle 50%. So I want you to visualize having 50% of the data right here in the center. So if I want to find this first z-score on the left, so I'm going to have two answers. I'm going to have the z-score on the left and the z-score on the right. They are symmetrical, so I want you to know in your brain that when you get one, it'll be the negative of the other one. So one of them will be one number and the other will be the opposite sign because of symmetry. But anyway, what is the area below for this first z-score? Okay, so when we do inverse norm of 0.25, we get negative 0.675. And so if that's the case, then symmetry gives us what value for the upper z-score? Positive 0.675. Okay, very good. Oh, is it? It doesn't round? Okay. Sorry. Oh, well, 6745 would round to 0.67. Oh, gotcha. Okay, gotcha. Okay, that's right. 0.6745. We'll go with that. Okay. All right. Now I want you to do 4, 5, and 6 tomorrow. So let's move on to number 7. Because this is the word problems. This is the key. This is like where we're headed. The main place that we are going with all this stuff. So whenever we get to our word problems, you pretty much always want to just start out writing down the things that you need to get from this. Okay? So I always just start off with that. And I read through it. So the Pizza Parlor franchise specifies that the average amount of cheese on a large pizza should be 8 ounces. The standard deviation is 0.5 ounce, half an ounce. An inspector picks out a large pizza and finds that pizza has 6.9 ounces of cheese. What is that, the X value or the Z score? It's your actual X data, your data piece. That's your X score that you got. If the pizza parlor is really putting 8 ounces of cheese on the large pizza, what's the probability? Find probability, find proportion of observations. When you find percentage, what are we going to end up using? Norm CDF. Oh, sorry, that was our Lego movie song. So we're going to eventually need to find a shaded area. But first, we need to get the z-score. All right, so get that z-score first. X minus the mean over the standard deviation. X minus the mean over the standard deviation. Okay, so negative 2.2 is our z-score. So that means we've got a curve right here. On average, or they should be 8. Well, we're down here at 6.9. What's the probability we would have gotten that value there? So that's a z-score of negative 2.2 or less. How do you want to find this area down here? We want to norm CDF. Okay, so if I'm going to norm CDF, you do not have to write down the calculator speak on your as you show your work. I do for the teaching part of it. So what is the lowest bound on this area? What's the negative infinity simulated by negative 99? What's the upper bound on this area? Negative 2.2 has to be that z-score. Okay? So that area becomes 1.39%. There was only a 1.39% chance that we would have gotten that pizza with that little cheese on it if they are really averaging 8 ounces of cheese. That's not very likely. So do you think they're really averaging 8 ounces of cheese? Probably not. Okay, that's where we're headed with this in next semester. But let's move on to this next one. If the amount of cheese on the pizza is 3 standard deviations below the mean, what is the amount of cheese, the minimum amount of cheese they can have in order to not lose their franchise? So we've got the mean and the standard deviation is the same. What are we trying to figure out? Yes, we want to know how much cheese is the least amount of cheese they can have and still be safe and keep their franchise. What is the z-score? Yes, 3 standard deviations below the mean is the limit that they will allow you. So when we go and do this, and we get x minus the mean over the standard deviation, and I algebraically solve it, the lowest, so if that inspector came in and he found less than 6.5 ounces of cheese on that pizza, they would be in danger of losing their franchise. Okay, so I just kind of skipped all the algebra steps. All right, so that's all we're going to do. Tomorrow when we come in, we'll start on page 16, and you're going to work, and I'm going to walk around and help.